Earth Systems 3209, Unit 3, Earth's Materials. References can be found in Chapters 2, 3, 6, and 7 in the textbook, and Appendix A and B in the Curriculum Guide. Unit 3, Topic 4.1. This topic will focus on the formation of sedimentary rocks, and will primarily focus on outlining and explaining how sedimentary rocks form. When we look at the formation of sedimentary rocks account for approximately 5% of all the Earth's crust. Regardless of this low percentage, approximately 75% of all the rocks that we see exposed at the Earth's surface are sedimentary rocks. When we look at the formation of sedimentary rock, we have different stages leading to the formation. These include, number 1, erosion and weathering, number 2, transportation, number 3, deposition, and number 4, lithification. All 4 of these stages will help in the formation of sedimentary rock. Text references can be found on pages 158 and 159 in the textbook. The first stage in the formation of sedimentary rocks is weathering and erosion. In reference to the rock cycle, the origin of sedimentary rocks begins with the process of weathering and erosion. Pre-existing rock can be broken down both mechanically and chemically to produce sediment. When we look at mechanical weathering occurs when the material is broken into smaller pieces which still retain the characteristics of the original material. One such example is called freeze-thaw action. And mechanical weathering is sometimes referred to as physical weathering, where the actual material physically gets broken into smaller pieces. During freeze-thaw action, water seeps into cracks within a rock. This can be seen in the representation in the diagram on the right. Once water seeps into the cracks, it could freeze. And when water freezes, it expands. Therefore, the crack itself will actually expand with the ice, and the crack will enlarge. After prolonged freeze-thaw action, the actual rock can split into 2 smaller pieces, and this is called mechanical weathering, or could also be called physical weathering. If we refer to chemical weathering happens when a material is altered by chemical action and a new material is produced, which is chemically different from the original material. Such examples occur in nature, such as oxidation reactions. If we look at any material made up of the metal iron, we notice that if iron is left to the elements, that is oxygen in the air and moisture, it will actually rust. So when iron rusts, it produces a new material called iron oxide. And this is a good example of an oxidation reaction. Other materials, such as a certain rock, in this case limestone, or even marble, that makes up headstones and also statues of the past. These materials tend to decompose when exposed to different chemical elements, such as acid rain. In the past, we see statues and headstones that disintegrate when exposed to acid rain. The second stage in the formation of sedimentary rock is transportation. Once the previous existing rock gets eroded and weathered, and it breaks down into different materials, whether the materials be physical pieces or chemicals that are dissolved in solution, they then are transported. Transportation helps in the erosion process. These erosional agents, such as water, wind, and ice, influenced by gravity, will transport the sediment to new locations, usually at lower elevations, where it is then deposited. Sediment is broken down during this transport phase, and this process is called abrasion. So the erosion phase and the transportation phase work hand in hand, whereas abrasion is a process by which it wears materials down into smaller particles. Think of a piece of sandpaper rubbing across a piece of wooden board. The wooden board will actually wear down, and it will produce sawdust, which in this case we could call sediment, or compared to sediment, and the actual surface gets smoother. This same process occurs in nature when ice with rocks embedded in the bottom of the ice in glaciers move down a mountain, and it will smooth and break down the rock material as it passes over it. Three main agents tend to transport sediment. These agents include water, which is generally moving, such as rivers and groundwater; ice, such as glaciers found in mountains, which tend to move down the mountain as gravity affects the ice to cause it to move down; and also wind. Wind can also transport finer sediment when blown, or if the wind velocity is high enough, it could actually transport larger materials. Once materials are transported to lower elevations, they are actually deposited. So eventually, the sediment will get deposited in a water environment, in environments such as lakes, rivers, seas, or more frequently, the oceans. In a dry area of the world, sediment can also build up and be deposited, and can accumulate in areas we call deserts. Sediment size will decrease the farther it travels into a lake or an ocean. This is referred to as sediment sorting. So if you look at the diagram to the right, we notice that as a lake, or within a lake, we could get sediment being carried by rivers. So rivers can flow into a lake. As it do, it carries sediment. The sediment then will get deposited according to size. So what the actual water environment is doing, it is sorting the sediment, where only the finer sediment will get carried to the farther reaches from the shoreline. Coarse sediment will deposit near the shoreline, and fine sediment will get carried farther from the shoreline. This is also the case where rivers flow into oceans. We generally see coarse being deposited near a shoreline, and the very fine sediment being carried out over the continental shelf to deep oceans. If we look at the diagram below, we can see the transportation phase of sediment particles. And again, we see the sorting according to size. So near the shoreline, where the water environment is relatively fast, the finer sediments will actually be carried by the water, and it will be carried farther away from the shoreline. But what we see here is the coarse-grained sediment will get deposited first, because there's not enough energy in the water to carry the coarser material out into the middle of the ocean, or out farther away from the shoreline of a lake. So we see coarse-grained sediments being deposited near the shoreline. These coarse-grained sediments usually form a rock called conglomerate, if the particles are round, or it could also form a rock called breccia if the particles are angular. So as we move farther away from the shoreline, we see moderate sorting a little farther, where we can get medium-grained sediment being deposited. So here you pretty well have a mixture of some coarse and some fine being deposited. As we go farther out away from the shoreline, we see the water current slowing down. And as the water current slows down, it don't have as much energy. And here we see the finer particles being deposited. So where we see moderate to fine, we generally see sand being deposited. And farthest from the shoreline, we see clay and silt being deposited, which will form a rock called shale. So shale is more or less consists of very well sorted particles, whereas the closer you get to the shoreline, we get very poorly sorted particles. So sorting will depend upon the distance you get away from shoreline, and the farther the sediment is transported out into the water environment. So increasing distance of transport, which you see here about a red arrow, the greater the degree of sorting. The fourth and final stage in the formation of sedimentary rocks is called lithification. Lithification will follow deposition, and during this stage, sediment may become lithified, which means turn to solid rock. Sediment is usually lithified according to two processes. The first process is called compaction. Compaction is when sediment is actually compressed due to the overlying material, which causes the material to compress. When the sediment size is small, the weight from the layers of sediment above can compact the lower layers to form solid rock. Primarily, compaction will affect only the very fine sediment, which would be silt and clay. So if you look at the diagrams below, we see that the bigger particles, which is made up of pebbles and sand, they compact, but they don't form solid rock due to compaction. It's only the very small, fine layers of silt and clay that actually can turn into solid rock by compaction. Also, if you look at this diagram, we will notice that the corresponding layers tend to decrease in volume as they get compacted. So the silt and clay layer here, which is in the sediment phase, when it forms into a solid rock, as represented over in the right diagram, we see that the shale layer, which forms from silt and clay, will be much thinner than the actual layer of sediment itself. This is due to compaction of the sediment. So as the silt and clay compacts, it can lithify and turn into a solid rock, which we call shale. So shale is formed from the lithification of silt and clay. When we look at the other rock types, namely conglomerate, sandstone, the bigger particles, they form solid rocks through a different process. They form solid rock through a process called cementation. The compaction do aid in the lithifying process, but it is the cement that actually sticks the bigger grains together. So over long periods of time, mineral matter dissolved in groundwater pass through pore spaces in cement, sticks the sediment particles together to form a solid sedimentary rock. So if we look at the diagram below, we see we have various sediment-sized particles here. And in between the particles, we see red cement. And this cement is carried by the water, which percolates through the pore space. So water with dissolved minerals, such as calcite and silica, which is two common natural cements, they pass through the pore spaces with the water. As the calcite and the silica pass through the pore space, the actual material will form on the surface of the grains. As it forms on the surface of the grains, it will tend to stick the grains together. So in this diagram, the cement is represented by the red color. Let's look at some examples. Example number 1. Which process is responsible for the lithification of sediments? So in the previous slide, we saw that the lithification process occurs 2 processes. Number 1, compaction, which will reduce the volume and cause the grains to become closer together. And number 2, cementing, is done when water-carrying minerals pass through the pore spaces, and the minerals will precipitate or form on the grains, which actually stick the grains together and will eventually fill in the pore space. So the answer to example number 1 would be A. Which processes are responsible for lithification of sediments? The answer would be A, cementation and compaction. Second question of example 1 says, which of the following is most likely to have formed farthest from the shoreline? If we look at a river, and a river flowing into either a lake or an ocean, the farther we travel from the shoreline, the less energy the water will have. Therefore, if the energy is going to decrease, we will notice our sediment size will be a lot smaller the farther we go away from the shoreline. Whereas near the shoreline, the bigger sediments will get deposited, and the finer sediments will still be carried out because it still has moderate energy. So farther away from the shoreline, we would see the finest sediment, which is silt and clay, and 2 of these make up a rock called shale. So our answer in this case would be D, silty shale. Example number 2 reads, which letter in the diagram below indicates where sediments is formed? So if we look at the diagram to the right, we see a variety of different geologic events that take place within this diagram. If we're looking for an area where sediment is formed, therefore sediment would be the particles that result when rock gets eroded and weathered. So if we look at high in a mountainous area or high in elevation, we see the elements of erosion, or the agents of erosion, which would be more effective on the rock. That would be water, wind, and ice. So therefore, A will be the best location where sediments will be formed. Then they would get transported and eventually deposited in water environments. So the answer to this question would be A. Locality A, or location A, would be where weathering and erosion would take place, which forms sediments. Your turn. Take the time to complete the following question. The prepared answer will follow on the next slide, so you can stop your recording now to study the question and answer the following question. Let's take a look at the following question. The question reads, which is the correct sequence in the formation of a sedimentary rock? So if we were going to look at the formation of sedimentary rock, the first thing we need is to produce sediment. Once we produce sediment, then we need to transport it. Once it gets transported, it is then deposited. And the last stage to form a solid sedimentary rock, it gets lithified. So if we look at our choices above, we can see that sediment is actually being produced by weathering and erosion. Okay. It then is transported, but transported is not included in our description here. So then we move to, it then is deposited, and then through lithification, it can get lithified into solid rock by compaction and cementing. So the best answer to answer which is the correct sequence in the formation of the sedimentary rock would be D. Sediments are produced by weathering and erosion. They are then transported, but it's not in the answer here. Then they are deposited. Then they get turned into solid rock, which is a process called lithification by compaction and cementation. So our answer to the question and solution would be D. Let's look at the summary. When we look at the formation of sedimentary rocks, we generally see 4 stages leading to the formation of a sedimentary rock. Sedimentary rock is eroded and weathered. This can be done by various agents of erosion and weathering, such as ice, water, and wind. The sediment that results is then transported. It can also be transported by the agents of erosion, which would be moving water, moving ice, or moving wind. Once it gets to an environment where the energy is very low, usually at low elevations, it is then deposited, generally in a water environment, such as a lake or a river. And once in the lake, river, or oceans, it then forms back into a solid, and this process is called lithification. And 2 processes, the process of compaction and process of cementation, will actually form the sediment into a solid sedimentary rock. So these are the 4 stages that are involved in the formation of sedimentary rocks.